Hi, everyone. Thanks for joining us today for our webinar on powering the future of AI. I'm Tom Hodson, an analyst at CB Insights, focusing on the energy transition and the future of oil and gas. Prior to CB Insights, I was a postdoc at Columbia University doing energy policy work, and I have a background in engineering. Before we start, I just want to give a quick intro to CB Insights. We're a market intelligence platform for high-stakes decisions. Our business graph is our predictive model of the world's companies and markets. With it, you can track and compare over 10 million companies and 1,500 markets, analyzing their strengths, weaknesses, likelihoods of success, and so much more. And now to dive into our webinar agenda, we will first start by talking about the energy production side of the AI data center value chain. We'll get into nuclear energy, geothermal, and grid storage. And then we'll end with a discussion on how AI is being used by energy companies to optimize energy operations. So as it mentioned before, we recently did a report on the AI data center value chain. And in that, one of our focus segments was on energy production. AI compute demand is set to triple by 2030 by some estimates. So this is going to require a lot of energy and power to be delivered to these data centers. And this is forcing hyperscalers to no longer rely on by purchasing renewable energy credits on the market or by doing virtual PPA agreements. Hyperscalers are now out there directly financing clean, firm energy to supply power for their data centers. So among this, nuclear, geothermal, and grid storage have seen a lot of activity to supply power for these clean, firm power for these data centers. We'll start with nuclear. Corporate mentions of data center and nuclear on corporate earnings calls has skyrocketed up to 56 at the end of the last quarter of 2024. So clearly, nuclear-powered data centers are on the mind of corporations. But is all of this corporate chatter translating to actual electrons delivered to these data centers? The answer is, well, not yet. In fall of last year, Microsoft and Constellation Energy had a sort of pivotal partnership where they agreed to recommission some decommissioned nuclear units at 3 Mile Island. And this partnership set off a flurry of activity in the tech community to partner with and invest in nuclear companies, including new nuclear technologies like small modular reactors. So small modular reactors saw almost $1 billion in equity funding in 2024, driven largely by this flurry of activity from tech companies at the end of the year. So for instance, we saw Google partnering with Kairos Power, Amazon partnering, investing in X Energy. Oracle had their own set of partnerships with small modular reactors. So this flurry of activity has boosted interest in small modular reactors. But there are some issues with small modular reactors. So if we go to the small modular reactor developers market on our platform and we click Generate Insights, we can see that supply chain constraints are a big issue for this market. Every pathway for small modular reactor companies, startups, requires this high assay, low enriched uranium fuel, or HALEU fuel. It's a very The supply chain for this fuel is very niche. There's basically only one global supplier. And so supply chain constraints have caused both NuScale and TerraPower, two leaders in the small modular reactors market, to push commercialization timelines to 2030 or later. And in addition, we can also see here a $3 billion contract between the US Department of Energy and Centrus Energy to develop a domestic supply chain for this HALEU fuel. So if we click into that a little further, we see on a recent earnings call by Centrus Energy, this company was talking about the role of national security in the development of the role that national security plays for the development of a domestic enriched uranium supply chain, and how that is boosting their ability to scale their operations as quickly as they can. They are currently the only domestic supplier of HALEU fuel in the United States. So small modular reactors are supply chain constrained. And then if we look back at the deal between Microsoft and Constellation Energy, the recommissioning of old nuclear power plants, well, we can also see on an earnings call by First Solar, the solar company, that the CEO of First Solar was mentioning that by his estimates, there are only 3 assets across the United States that can be economically recommissioned by 2028. And so that is both very small, only 3 assets. And additionally, 2028 is not tomorrow. So based on those 2 factors, nuclear may provide a significant amount of power for data centers 5 or 10 years down the line, but we need power tomorrow. And so there's going to be other sources of energy that we're going to have to invest in order to get that clean, firm power that we need for data centers. So the long timelines of nuclear has pushed interest in sort of middle distance solution, next generation geothermal energy. So interest in geothermal energy and conventional geothermal energy has been popping up. For instance, Google recently partnered with Baseload Capital to provide conventional geothermal energy for Taiwan, to power their data centers in Taiwan. And we see that just a simple 10 megawatts of geothermal there is doubling the national capacity of geothermal in Taiwan. And so the interest is there for conventional geothermal, particularly in low-hanging fruit regions like Southeast Asia that are heavily reliant on coal and fossil fuels to power their grid. But in order to expand to other locations, this requires new technologies, new geothermal technologies to be developed. Now we can go to the geothermal power providers market on our platform and click to the scorecard tab that we see here to take a look at what sort of technologies and business operations are geothermal startups doing in order to gain an edge in the market. And from this, we can pull out 3 leaders in the geothermal space. We see Fervo Energy, which is doing horizontal drilling for their geothermal. Baseload Capital, as we mentioned, doing more of a conventional geothermal approach. And Evor Energy, has developed a closed-loop geothermal technology. Two things I would like to note is both that Fervo Energy is sort of leading in terms of commercial maturity, historic partner of Google. They recently completed a commercial pilot project for their geothermal technology for powering data centers in Nevada. but baseload and EVOR aren't too far behind in the commercialization efforts. And the other thing that I wanted to note was the sort of oil and gas DNA that's found in, for instance, Fervo and EVOR. So horizontal drilling, closed loop technology. These are the sorts of things that you found in the shale revolution in the oil and gas industry. And you don't need to look too much further to find evidence of the oil and gas's fingerprint in geothermal. So Fervo Energy, made up of ex-oil and gas players. EVOR is operating in the oil sands region of Canada and Alberta. So we can see the pathway of oil and gas to geothermal. And additionally, we can see that now oil companies themselves are starting to get interested in this area. So on a recent earnings call with Ormat, a geothermal leader in the space, they talk about a partnership with Schlumberger, or SLB, a oil services provider. And there's two things that we can see here is, first, they're talking about providing geothermal, conventional geothermal, to data centers at pretty high rates, $100 per megawatt hour. So again, the demand for conventional geothermal for data centers is there, and they're partnering with oil and gas companies like SLB to both develop, to take this knowledge of subsurface technologies that the oil and gas industry has developed and bring that to conventional geothermal as well as next generation geothermal, so something like enhanced geothermal systems. This is what Fervo Energy is doing. So geothermal, lots of interest in there from the oil and gas sector. The last segment that I wanted to talk about is grid storage and how it plays a role in data center operations. So looking at an earnings call from Enersys, which is a large battery maker, we see that this company is already talking about 10% of their total revenue being made up by data centers, specifically for this use case called uninterrupted power supplies, or UPSs. These are lithium-ion batteries that provide power to the data centers whenever the grid becomes unreliable. And so a large portion of the revenue already going to data centers using lithium-ion batteries. In addition, lithium-ion batteries, just in terms of grid storage, are the vast majority of battery storage on the grid is these types of lithium-ion batteries. But recent fires and safety incidences at grid storage sites have sparked a reconsidering of this. So for instance, there's a large battery fire at one of the world's largest battery storage sites at Moss Landing. And this, combined with plenty of battery fires that happened at grid storage facilities in South Korea, is making grid operators sort of rethink lithium-ion as a source of energy storage for the grid. And so one alternative to lithium-ion is sodium-ion. So sodium-ion has the benefits of being less prone to fire. The materials and supply chain for sodium-ion batteries are well established, more abundant materials. And in addition, these batteries can are better at operating at elevated temperatures, and can also be cheaper on a power basis, a power density basis, with respect to some lithium-ion battery chemistries. And so sodium-ion batteries saw a huge influx of equity funding in 2024 to the tune of $320 million, well above any of the amount seen in previous years. And 80% of this came from really just there's three deals: Nature and Energy, Peak Energy, and TimeAt. Nature and Energy doing a very large Series F round, um, uh, and Peak Energy and TimeAt doing smaller but pretty substantial earlier stage rounds. And so the fact that Peak Energy and TimeOut are doing substantial early stage rounds suggests that this market has a lot more room to grow. Nature and Energy has been working in this field for over a decade. They're the leader, one of the leaders in the space. But some of these earlier players can catch up. And so if we look at Nature and Energy, if we go to their profile on our platform and see what they've been up to through our scouting reports, we can see that they recently presented their sodium-ion batteries at a ARPA-E Energy Summit. And they talk about how they're targeting high-performance data centers for their batteries. We see that they announced a $1.4 billion battery production facility in North Carolina, really trying to scale this technology. And one other interesting thing, if you go through their scouting report on this company, is that they're positioning their production to be as much of a direct drop-in for lithium-ion batteries as it can be. So you have these multi-billion-dollar battery production facilities that are being built or announced by auto OEMs or industrial conglomerates. With dampening EV demand, it very well might be that we can see that some of this production for lithium-ion batteries that have traditionally gone to electric vehicles, some or all of this production might be switched over to sodium-ion batteries to be put on the grid or to be used for data centers. And again, this is only possible if you can have your sodium-ion batteries be a direct drop-in or as much of a direct drop-in as you can for lithium-ion batteries. So kind of an interesting approach by this company here. And last, just kind of like wrapping up everything, the current head of the Department of Energy, Chris Wright, has a track record in the oil and gas industry, but we can use his activity in the oil and gas industry to kind of get a sense of where the Department of Energy will be heading going forward. So with this new administration and changes that are happening at the federal level, we can see that looking back, Liberty Energy, which was the company he founded and he was the CEO for has invested in Fervo Energy, the geothermal company we discussed before, invested in small modular reactors, and they invested in Natron, sodium-ion batteries. So as the Department of Energy kind of figures out their path going forward in this new administration, do expect that there'll be policy tailwinds for these types of technologies that Chris Wright, head of the Department of Energy, has already kind of sussed out through his previous role as CEO of Liberty Energy. And now last, I just want to switch from talking about the energy going to the grid to how to power AI, to how AI is being used by energy companies. So earnings call mentions of unstructured and AI peaked around the time of the release of ChatGPT back in late 2023, has remained elevated, but has since seen an additional jump in the first quarter of this year. And unstructured data is particularly well suited to be used by these new large language models because they can ingest whatever type of data and then provide insights and analysis onto that data. There's no cleaning or structuring that really needs to be done. And energy companies have just a plethora of decades worth of sensor data, field reports, equipment logs, all these sorts of things that can go back and used by these new models and in sort of unstructured way to provide insights into operations going forward. We're seeing this happen in other similar fields. So in the healthcare space, um, we see that companies are targeting unstructured data to gain insights in topics like drug delivery. So causally, we see a customer uh, sentiment report talking about how that the technology that they have is um, really good at generating insights based on unstructured data that can be used to accelerate the development of drug discovery. And similarly, when we dig into the earnings calls of energy companies looking at Saudi Aramco, they recently talk about how they've built out this AI model that makes use of 90 years of proprietary seismic data and logs that and surveys that they have logged over the years, and how this is reducing operation costs, making it less carbon intense to produce the oil. So we're already seeing companies like Saudi Aramco um, making um, making use of unstructured data, and we expect to see this trend continue going forward as other companies begin to take all of the unstructured data that might have gone previously unused and try and funnel it into these new AI models to try and gain insights into their operations. And with that, that is our webinar. Thank you for attending. Feel free to reach out if you have any questions, and take care. Have a good day.